Hey, good morning. So I am not going to be there today and need to go along and give you some lessons. So if you haven't already, let's take out your purple packet and we're going to day 4. We are still factoring, and in order to factor, we need to go through our paces, meaning there are certain steps that we need to take. So the first step again is 1, to look for a greatest common factor. 2, difference of squares, which we'll talk about Thursday. And 3 is Xbox, and that Xbox only works for trinomials. Okay, so with those in mind, let's start with our first one. If you want right now, and see if you can do these on your own. So I'll pause here and let you try to work on 1, 2, and 3. And I'm sure you can do some of it on your own. And if you need some help, then just wait and go ahead and do it with me in a minute. So you can pause this video and work on these problems now. Okay, and I'm back. So as I look at the first problem, I say 3x minus 9. I'm trying to find a greatest common factor for both of those, and always looking at the smallest coefficient first. I see I can divide by 3. The x is only in the first term, so it cannot be a common factor with the second one. So 3 is my greatest common factor, and I factor that out in front. And when I divide, 3 divided by 3 is 1. And 1 times x is x. Minus 9 divided by 3 is 3. And that is your final answer. For number 2, again, always start with step 1, looking for the greatest common factor. And I have 14 and 21. Looking at the smallest coefficient, 14 is not a factor of 21. So I go to the next highest factor of 14, which is 7. And 7 is a factor for both of these. So I am going to factor out a 7. And then I see I have an x to the third and an x. So the most I can factor out from both is x to the first. So my greatest common factor is 7x. And when I factor that out, which means I'm dividing, 14 divided by 7 is 2. X to the third divided by x to the first. Remember, we are subtracting the exponents when you divide powers with the same base, and that gives me x to the second minus 21 divided by 7 is 3, and x to the first divided by x to the first simplifies out to be 1. 3 times 1 is 3, and so this is our factorization. Lastly, I look at this final term, and there are 4 factors. So right away, I'm like, okay, 4 factors. I need to factor by grouping. So I group the first 2 together and the last 2 together. So looking at the first 2 problems only, there we go. I see that I have a 5 and a 5, so I can factor out a 5. I have an x to the third and an x squared. The most I can factor out from both is x to the second. So that is my greatest common factor. So I factor that out in front. And when I simplify and see what I have left, 5 divided by 5 is 1. X to the third divided by x squared. Subtract the exponents, and I get x to the first. minus 5 divided by 5 is 1, and x squared divided by x squared simplifies out to be 1. So that's for the first two, plus, here I see I have a 2 and a 2, so I'm going to factor out a 2. So the 2 comes out in front. And what do I have when I'm done? I have 1. 2 divided by 2 is 1. With an x left, minus 2 divided by 2 simplifies to be 1. Looking at this, I have a product of two terms plus a product of two terms, and this is the term that is common to both, so that essentially becomes my greatest common factor. It's definitely common, so I really would like to see in the future you take that and factor it out in front. So I'm going to put 1x to the first minus 1, or you can just even leave it as x minus 1 out in the front, times quantity 5x squared plus 2. And that is your final answer. Okay. So those are the 3 answers for day 4. Didn't even get to the Xbox trinomials, but let's go now and find our notes page. Notes page. And if you have forgotten, let's see. Looks like, at least for some of my classes, we maybe did not get down to this last one. Okay, so again, I'm going to put these over on the side. 1, we always look for a greatest common factor. 2, difference of squares, which we have not gotten to. And 3, the X box. All right, so x squared minus 3x minus 4. And all of these examples are where my a value is equal to 1. If you remember, the standard form, and I might not have talked about this in every class, but standard form for this is ax squared plus bx plus c, okay? ax squared plus bx plus c. All right, so in this particular problem, a is equal to 1, that's the 1 in front, b is equal to negative 3, and c, my constant, is negative 4. All right, so looking for a greatest common factor, I've got a 1, a negative 3, and negative 4. And that just would be 1 as greatest common factor, which is not helpful. Factor out a 1, you get the same thing. I see an x squared and x, but no x in the last term. So I can't do a greatest common factor. It is not a difference of squares, and so I go to X box. In X box, I am putting the value of a times c up here at the top. My a value is 1. My c value is negative 4. 1 times negative 4 is negative 4. And my b value, and I remember b stands for bottom, so b is on the bottom, and that is negative 3. So I'm looking for factors of negative 4, two numbers that multiply to give me a negative 4, and add to give me negative 3. So I'm just going to put the factors of 4 here. Because it's a negative 4, I know that one of these is going to be negative, and because this number on the bottom is negative, that means the larger digit larger number is also going to be negative. So I'm looking at 1 and negative 4, and it doesn't matter where, or if you put 1 first or if negative 4 first, but you put the other one in the side. Okay? So when I am next drawing my box, I put the entire first term of the trinomial in the first box. I put the last term, the constant, in the last box. And in the middle two, or these on the diagonal, I put these two numbers that we just found with 1x, or times an x, which gives me these two. Okay? So then I look at each row and I find the greatest common factor of this row, and I write that over to the left. So I have a 1 and a negative 4. That's going to be a 1. X squared and x to the first. You always have to use the smallest exponent, so that is an x to the first. Looking at my second row, I have 1x and negative 4, kind of just like what we had before. That would be a 1. And my second term does not have an x at all, okay? And whatever is the sign of the first value you have, that is what you need to use for the sign as you factor it out, okay? I don't think I said that well. I think I said whichever one is closest to the edge, and it works out the same, but it's better if you say the first factor's sign. So then I am looking at the column, and I see 1x squared and 1x, 1 and 1. Greatest common factor is 1. X squared and x to the first is going to be an x to the first. Here I have then a negative 4 and a negative 4. The negative 4 here, the negative 4x, I should say, is the first factor, so I have to factor out that negative. And negative 4 is going to be negative 4. So these are my two sets of factors, and you do need to rewrite them as separately. So 1x plus 1 in parentheses times 1x minus 4. And that is the factorization of that trinomial. Okay, so these are the check. Doesn't look like I had that last one up. That is unfortunate. Okay, maybe just that didn't make sense. Skip that part. Sorry about that. Here we go in the check. So x squared plus 7x plus 6. Here's my paces. Meaning, 1, do I have a greatest common factor? If you do, factor that out first. 2, difference of squares. And 3, x box for any trinomial. So looking at A, I don't have a greatest common factor. It's not a difference of squares. So we go right away to x box. And I'm going to say, and line these up and say A is equal to 1, B is equal to 7, and C is equal to 6. So in my x box at the top, I want A times C, so that's 1 times 6, which is 6, and B, which is 7. Okay, and on the sides, I need to find two numbers that multiply to give me 6 and add to give me 7. All right, Well, when you write down these factors of 6, the only time that the sum is going to be more is if you use 1 and the number itself. So I know my numbers are 1 and 6. 1 times 6 is 6, and 1 plus 6 gives you 7. All right, so we're going to do the X box down here. And the first box is the first term. The last box is the constant, or the last term. And the 2 in the diagonal are the two numbers that you had multiplied by whatever variable you have. So 1x and 6x. Now looking at each row, find your greatest common factor. 1x squared and 6x. You could put a 1 in front. And I have an x. 1x and 6. I have a 1 here. Excuse me, and there is no x there. Looking at the column, right here, first term, x squared plus x, 1x. That is going to be 1x. And 6x plus 6. You've got a 6 and a 6. So that is plus 6. X, there is no x in the second one. So putting this together, these are your two factors. 1x plus 1 times 1x plus 6. Okay. Looking at the second one, same story as what we're looking over here. Greatest common factor, difference of squares, X box. So greatest common factor, I've got, anytime it's a 1 in front, the greatest common factor is only going to be 1, and that's not helpful. We don't have a difference of squares, so we go right away to X box. So A is 1, B is -8, C is 12. And so I do my X. A times C is up here. 1 times 12 is 12. And B is -8. So I'm looking for two factors of 12 that add to give me -8. So as I look at them, I see the 2 and the 6, and I also know that a negative times a negative can give me this positive 12, and adding them together gives me -8. So this is going to be -2 and -6. So putting my box together, first term goes in the first box, last term goes in the last box, and the 2 that we just found multiplied by the variable x go in on these diagonals. So greatest common factor of 1 and -6 is going to be 1, which I'm not going to write that down now. You'll get to seeing these more eventually. And x squared and x, the greatest common factor is going to be 1x. -2, that is my first number that I'm looking at. I need to factor out that negative with it. And 2 is also a factor of 12. There's an x, but the second one doesn't have an x, so that is my factorization there. Looking at the columns, an x squared and -2x is going to be an x, and -6x and -12. The first one has a negative, factor out the negative, and 6. So my factorization here is x minus 2 times x minus 6. And the last one, x squared plus 3x minus 40. I have 1 in the front. Anytime you have a 1 with a trinomial in the front, greatest common factor is going to be 1 for your coefficients and your constant. That's not helpful. I don't have an x in the last term, so we're going to use the x box. So a is equal to 1, b is equal to 3, and c is equal to negative 40. So I need my x with a times c. A is 1, c is negative 40, and b on the bottom is 3. So I'm looking for factors of negative 40, which I'm just going to think 40 for a minute here. 2 and 20, 3, no, 4 and 10, 5 and 8, 6, no, 7, no. And I see this. I know it's negative, so one's going to be positive, one's going to be negative, and because this one is positive, the larger digit or the larger number is also going to be positive. So that makes this a negative 5 and an 8. And I do my box or the square, whatever you want to call it. First term, x squared. Last term, negative 40. And the middle 2 multiplied with my variable, negative 5x and 8x. Looking at the row, greatest common factor, x times x, and factors of 8x. So 1 and 8 would just be 1. X squared and x is 1x. Negative 5 here in the bottom row. First term has a negative, so I need to factor out that negative, and that's a 5. And the x there isn't 1 in the second one. X squared for the column, and negative 5x. This is a positive, so this is going to be a positive x over here. And 8x and negative 40. 8 and negative 40 is going to give me positive 8. And so writing this down, that's the b from above. I have x minus 5, or 1x minus 5, times x plus 8. Okay. And I think that is all we have for today. So your homework is homework number 2. And I need to check and look at this really quickly. I don't want to end this, though. Okay, I was afraid that was going to end it. So looking at homework number 2, let's just double check this. Ah, yes. So factoring quadratics, trinomials where a is equal to 1. So you have 6 problems here on the front and 5 problems on the back. And it says factor each polynomial if possible. If the polynomial cannot be factored using integers, write prime. Okay. So if they cannot be factored, if you can't think of values that would work, then write prime. I'm trying to look at these really quickly to see if there's one that is prime. I think number 10 as I look at it. So let me show you what I'm talking about here. So GCF, do I have one? And since this is a equals 1, I do not. No difference of squares, and so we go right to X box. A is equal to 1, B is equal to 5, and C is equal to negative 13. So in my X, I have a times c, which is 1 times negative 13, and b, which is 5. So I'm looking at factors of negative 13. 13 is a prime number that add up to be 5. Well, there's no way that when I try to do this, I can find either negative 1 plus 13 gives me 12, or I can have 1 plus negative 13, which adds to give me negative 12. It does not ever going to add up to 5. So for number 10, that's where you would write prime for right now. Okay, so I need you for homework. This is due on Tuesday. Finish the rest of these 5 problems on the front and these problems on the back, and make sure you have this ready to turn in for Tuesday. Also, just to let you know, I am going to be out for the rest of this week. My father did pass away last night, and so I am going to be back in Ohio helping my mom and sister with arrangements and the services for my father. So I expect to be on your best behavior, to listen to these videos and try to do the best you can, and I will do the best I can, and hopefully I will see you back a week from today. Thanks. Bye-bye.